Welcome. In this video, we're going to do a few examples where we apply this instantaneous rate of change formula to find the instantaneous rate of change at a specific given input, or essentially an x value. So this formula written on the page gives us instantaneous rate of change. We're looking at the limit as h approaches 0 of the difference quotient f of a plus h minus f of a divided by h. And of course, that a value is going to come from that given input. Whatever our x or independent variable is, we're going to be given a value or a constant for that, and that's where we're going to be finding the instantaneous rate of change. So let's do a few examples. For the first example, the function we're going to consider is this position function s of t equals 3t squared. And we're going to find the instantaneous rate of change at or when t is equal to 10. All right, so t equals 10. 10 is going to be my a value. So let's set this up. In order to work through this problem, I'm going to write out my entire limit, the limit as h approaches 0 of, we're going to have s of 10 plus h minus s of 10 all divided by h. So we have the limit as h approaches 0, s of 10 plus h, that's 3 times the quantity 10 plus h squared minus 3 times 10 squared, all divided by h. So when I plug 10 and 10 plus h in for t, I get these two different expressions in the numerator, all of which is divided by h. So stop, make sure you can get to this step and that it makes sense to you. At this point, we're just going to perform algebraic operations to simplify what we're looking at here and eventually cancel h. Remember, we always want to cancel that h in the denominator because in order to evaluate the limit, we need to plug 0 in for h. And right now, if I tried to plug in 0, I would get an undefined value, which is not what we want. So let's see. I have the limit as h approaches 0 of 3 times 10 squared is 100, twice the product, that's going to give me 20h plus h squared, minus 3 times 100 over h. I'll distribute here the limit as h approaches 0, that is 300 plus 60h plus 3h squared minus 300 over h. You should notice that 300 minus 300, that's going to cancel. And oftentimes this last piece here should always cancel. If you're dealing with a rational function, that means you've got a fraction in there. It's not always going to cancel, but if any polynomial, linear, or quadratic, this last term or last set of terms, whatever you have there, that should go away. So now I have the limit as h goes to 0 of 60h plus 3h squared over h. You'll notice that all of my terms have an h, so I'm going to factor an h out in the numerator. That's h times 60 plus 3h, all divided by h. Here I have one h in the numerator and one h in the denominator, so they will cancel. I have the limit as h goes to 0 of 60 plus 3h. Once I've canceled that h, now I'm going to plug my 0 in, and I do not have to write limit anymore. So this is 60 plus 3 times 0, or 60. So 60 represents the instantaneous rate of change and essentially represents the slope of the tangent line at that point at t equals 10 on my original graph, s of t equals 3t squared. And so I've drawn here a graph. It's not to scale, but representing s of t. And at that point 10, my output value would be 300. And if we were to zoom in and draw a tangent line, a line that's touching just at that one point, we would see the slope of that line, the rate of change at that point, the slope would be 60. And it makes sense that that's 60 because this is a really steep parabola. As the further we shoot out on that x, or the input axis, the t-axis, those y values are really shooting up into the air. So the slope is positive 60 at that point t equals 10, or 10, 100, the ordered pair on the graph. Let's do one more example. In this second example in the video, we're going to find the instantaneous velocity for the given function s of t equals 4t squared minus 5t minus 10. This is my position function at time t equals 3. Now, the last problem said instantaneous rate of change. This one says instantaneous velocity. What I want you to recognize is that velocity is a rate of change. I know we've mentioned this previously, but we use s for our position function. So this gives us our location, and then velocity by using this limit formula. We're going to find that rate of change, or the velocity at which this object at some position at time t is moving. So let's go ahead and apply our definition. Now in this case, we're going to be using 3 for our a value. So we're going to say, well, we've got the limit as h approaches 0 of s of 3 plus h minus s of 3, all divided by h. So what does that look like? That looks like the limit as h approaches 0 of, I have 4 times 3 plus h quantity squared minus 5 times 3 plus h minus 10 minus, now we're going to plug in just 3, so that's 4 times 3 squared minus 5 times 3 minus 10. All of that is divided by h. So if you get to this step, I know you know how to set it up. We just need to do our algebra to simplify correctly. And so what we're going to recognize here is we have to FOIL, we have to distribute. This is just going to give us a constant. And as I said before, this constant should completely evaporate if I multiply this out correctly. So if that's not going away, you probably made a mistake. So let's look at this. And the limit as h approaches 0, I have 4 times 3 squared is 9 plus 6h plus h squared, I FOILed that, minus 15 minus 5h minus 10. And over here, I have 4 times 3 squared, so that's 4 times 9, 36. 36, take away 15, take away 10, 36, take away 25. That should leave me with 11. So I have minus 11 here. Again, this is still all divided by h. So now I have the limit as h goes to 0. This is 36 plus 4 times 6, 24h plus 4h squared minus 15 minus 5h minus 10 minus 11 all over h. So now I have 36, take away 15, take away 10, 25, take away 11. All of those will cancel out. So I told you this end number, whatever we have here, that's always going to cancel. If it doesn't cancel, you've probably made a mistake. This is now the limit as h approaches 0. 24h plus 4h squared minus 5h over h. Again, I see some like terms that I can sum together. So the limit as h goes to 0, 24, take away 5. That is 19h plus 4h squared over h. Factoring an h out in the numerator, we have the limit as h approaches 0 of factoring out an h, so h times 19 plus 4h, all divided by h. Those h's will cancel. I have the limit as h approaches 0 of 19 plus 4h. Once I've canceled that h, now I can plug my 0 in for my h value, and I do not have to write limit anymore. This is 19 plus 4 times 0, or 19. So my instantaneous rate of change, or the instantaneous velocity for this position function, is 19, and that is at the moment where t equals 3. So that's how we do these instantaneous velocity, instantaneous rate of change problems. I hope that helps you understand the procedure, the process. Please feel free to email me if you have any questions or concerns.